Okay, so today we are discussing about a very confusing topic that is called as distance of closest approach. A very interesting topic here. So here, let us see, let us do the problem of distance of closest approach here. Now, find the distance of closest approach in this case here. If you observe, there are two boats. This is boat 1 and this is boat 2. Or you can take ship 1 or ship 2, or whatever it may be. These two boats or ships are having a distance of 10 kilometers between them. They are having a distance of 10 kilometers between them. But if you observe here, boat 1 is moving towards the boat 2, whereas boat 2 is moving towards right with a speed of 8 kilometers per hour. And boat 1 is moving down, or ship 1 is moving down with a speed of 6 kilometers per hour downwards. He's asking us to find out what is the distance of closest approach. How are you going to imagine this situation? Let us consider this is a boat 2 and this is a boat 1. If you observe, previously both are like this. Now after certain time, this will move right, this will come down. This will move right, this will come down. This will move right. Okay, so this is the situation which you need to imagine here. So when this is coming down, this is moving right side. You need to find out what is the distance of closest approach in this case here. So how are you going to find out the distance of closest approach? For that, if you imagine correctly, then you can solve the problem in a very easy manner. Here, imagination works maximum. Imagination is powerful than knowledge. If you have got a correct imagination, then physics will become the easiest subject in the world. So, I love physics. I'm mad of physics. I enjoy doing physics, and for me, if you observe, I explain in the most easiest manner because I feel that it is the most easiest subject because I have got a very strong imagination. If you imagine the way I am going to imagine, then it will become very easy even for you also. Let us see what is going to happen now. So this boat is coming down with a speed of 6 kilometers per hour. This boat is moving right side with a speed of 8 kilometers per hour now. Now you need to do one thing. You need to observe that you are at this place. Okay, you are sitting here. So what is the meaning of frame of reference? Frame of reference, you consider it as a ship 1 here. So frame of reference you can consider as ship 1 is the frame of reference. What do you mean by frame of reference? Frame of reference means, let us imagine you are sitting in boat 1 and observing boat 2. When you are sitting in boat 1 and observing in boat 2, what do you feel? You feel one thing, that your boat is at rest now. Your boat is at rest with respect to you. Okay. Then you feel that the boat 2 is coming towards you. How? Let us see. As this boat in which you are sitting is moving down with a speed of 6 kilometers per hour, but as you are sitting in boat 1, you feel that your boat is rest and that boat is coming towards you. That boat is coming towards you with a speed of 6 kilometers per hour. Okay, with a speed of 6 kilometers per hour. So this is you are going to observe here. Let us write this here now, 6 kilometers per hour. So this is 8 kilometers per hour, this is 6 kilometers per hour. Then what is the resultant of these two here? 6 and 8, if you observe, what is the resultant? So resultant is nothing but this is just like a hypotenuse here. So a good news is this is hypotenuse because this is making 90 degrees here. Okay, so this is 90, 8, 6. Okay, then this is going to be square root of 6 square, 36, and 80. I mean 8 is just 64. So under root of this is going to become 100. That is 10 here. So resultant of these two is 10. If this is 8, this is 10. Then this is how much? Let us see. So this is 6 kilometers per hour. It is given already in the problem. This is 8 kilometer. Why I am writing 6 kilometer? Because as you are coming with a speed of 6 kilometer per hour and you are sitting in first board, you will become frame of reference. You will feel that the boat is coming towards you. When you are sitting in a bus, and when you are moving to a building, you feel that a bus is at rest and building is coming towards you. That is the called as frame of reference here. That's it. So now, as this for you, this boat coming towards you 6 kilometers per hour, but the boat is moving right side. So the resultant velocity of these two will become 10 kilometer per hour. Okay, 10 kilometer per hour. Okay, so then if I extend this one and drop one perpendicular here, okay, actually this is going to be the resultant velocity. For you, this boat appears to move in this direction. For you, this boat doesn't appear to go in a horizontal way. You feel that boat is coming in a according to the direction of hypotenuse. For you, you feel that boat is coming along the direction of the hypotenuse towards you. That's it. Okay, so let us see what is going to happen here now. So you know this triangle here. The magic is this is the triangle here. It's a very simple problem, no need to worry here. This is 37 degrees, this is 53 degrees, and this is going to be 90. Okay, so this is 3, this is 4, and this is 5 here. Okay, so now if you observe how much it is, this is 8, this is 8, and this is 10. Means what is the meaning? You have multiplied this with 2, this will become 8. You will multiply with 2, this will become 10. So this is 10 and this is 8. The angle between 10 and 8 is 37. That means this angle is 37 degrees. And what is in between 10 and 3? Okay, so this will become 3 2s are 6 here. Okay, so therefore the new triangle is this hypotenuse is 10 and this side is 8 and this side is going to become 6 here, because ratios of the sides will be same whether it is 3 4 5 or it is 6 8 and 10 like this. Okay, whatever it may be. So now this is 37 means this is going to be 53 degrees here, because 53 degrees sides adjacent to 53 degrees are 6 and 10. Here also 6 and 10 are the adjacent sides of 53 degrees. So now you got this as 10 here. You need to find out this distance here. Minimum distance will become this here. Actually, you can draw the lines in different directions. Here also you can draw the line, here also you can draw the line, here also you can draw the line. But the line which is making exactly perpendicular, which is drawn exactly perpendicular to this direction of boat will become the minimum distance here. This is going to become the minimum distance. If you draw one line like this, that is not going to become the minimum distance. You know minimum distance is nothing but the perpendicular line drawn exactly. The shortest distance is nothing but the perpendicular line drawn here. Okay, so therefore we need to find out this distance here. Okay, so how are you going to find out the distance here? Let me draw one separate triangle for distance here. Okay, so this is a separate triangle I am drawing here for finding the distance. So now this triangle I am drawing here. So this is 90 degrees, this is 53 degrees, and this is going to become definitely 37 degrees according to this triangle also. So this triangle and this triangle are separate triangles. This triangle is formed here and this triangle is formed over here. Okay, so this is 53. Okay, and this is 90 means definitely this is going to be 37 here. And you know this is 10 kilometers. You know this is 10 kilometers, and the adjacent sides of 37 degrees means one is 10 means another is definitely becomes 8 kilometers here. Okay, so 53 means if one is 10, the other is going to become 6 kilometers here. Okay, so therefore I got this distance also, I got this distance also. Here D minimum we need to find out the distance of closest approach. Therefore, D minimum is going to become 8 kilometers. Okay, very simple. Just finding the ratios of this 37 degrees, 53 degrees and 90 degrees. That's it. You got the answer. Therefore, your answer is a distance of closest approach, which is called as a minimum distance between the two boards. Here, we need to consider the relative velocity here. What is the relative velocity? The relative velocity is nothing but 10. So in this direction we are considering the relative velocity, and that relative velocity is nothing but 10 kilometers per hour in this direction. Okay. So therefore your resultant velocity of the boat is like this, because for you a boat doesn't appear to move like this. For you, as you are sitting in the first boat, for you the boat appears to move along the hypotenuse. And here you need to find out the distance of closest approach, that is called as the minimum distance here. And the minimum distance, how much you are getting? You are getting that as 8 kilometers is the distance of closest approach. Now, the second part of the problem is he is asking how much time it will take so that the two boats will reach to the minimum distance. For example, this boat started here, this boat started here. What time it will take so that they will reach to the distance of closest approach? That time also you need to find out here. That time also you need to find out here. How are you going to find out the time here? So time is equal to distance by relative velocity. You can consider this distance and this velocity. Then you can find out the time here. Okay, very simple. You need to find out this distance and you can take the relative velocity along this distance. Okay, it's very simple. You know this distance, we got it as 6 kilometers just now. Okay, if you take a triangle for only distances separately, if this is 10 kilometers already given in the problem, this is 10 kilometers given in the problem, okay, and this is 6 and this is 8, we found by using this concept of Pythagoras theorem here. Okay, so very simple concept. Therefore, this distance along the hypotenuse, you know, according to this concept, it is going to be 6 here, and velocity in this direction is going to be 10 kilometer per hour. Okay, and distance is going to be 6 kilometers. Therefore, time is going to be 0.6 hours. Time is going to be 0.6 hours. It's a very simple problem. Okay, so if I do one more problem, then complete confusion will be eliminated. Okay, let us see this next problem here. So this is a somewhat different problem. Okay, so here you are seeing that one boat is here and the other boat is here. Already one boat, which is the first boat, is not moving along the second boat, but it is moving in this direction, making a speed of 8 to 2 kilometers at an angle of 45 degrees with the vertical. This boat is moving in this direction at an angle of 45 degrees with the vertical. And these two boats, if you observe, they are at a distance of 20 kilometers here. 20 kilometers here. So if I draw the separate diagram now, so that you will get more clarity about these two boats, what is the relative velocity and how they are going to appear now. See here how they are going to appear now. So this is the boat which is moving with a speed of 8 to 2 kilometers. Next, if you observe this one, so I will draw one line here. Okay, so what are the components? If 8 root 2, this is going to be 45. Okay, so if hypotenuse is 8 root 2, definitely this side will become 8 kilometers per hour and this will become 8 kilometers per hour, definitely. Okay, so because hypotenuse is 8 root 2, if two sides of a square, if you observe, if this is 8 and this is 8, definitely this is going to be 8 root 2, because this is 45 and this is going to be the 45 degrees. So this is 8 kilometers and this is 8 kilometers. Now let us consider the frame of reference. What do you mean by the frame of reference here? Let us imagine that you are sitting in the first boat now. When you are sitting in the first boat, how do you feel? What do you feel? Second boat is moving. Okay, so as you are moving in this direction, you feel that your components along the horizontal is 8 kilometers and vertical is also 8 kilometers. Then when you are considering this the first boat is going to become the frame of reference. This first boat is called as a frame of reference, is the first boat. Frame of reference. You are sitting here, though, therefore you will become the frame of reference. Means you are going to observe the second boat here. Then how are you going to feel now? as you are sitting in the first boat and your vertical component is 8 kilometers per hour, you feel that this boat is moving towards you now, because when you are going in a bus towards a building, you feel that building is coming closer with respect to you because you are at rest with respect to that bus here. Okay, so therefore what I am going to say here is, when you are sitting in this boat and your vertical count is 8 kilometers per hour, you feel that this boat is moving towards you now. This boat is moving towards you with a speed of 8 kilometers per hour now. But already this boat is moving with a speed of 14 kilometers per hour towards the right. Okay, towards right. As you are moving like this, your horizontal component is right side. You are moving right side. You just imagine that when you are going in a bus towards the road, I mean towards this direction, you feel that trees are moving left with respect to you. When you are moving in a bus, you are going to become the frame of reference. You feel that with respect to you, bus is at rest and trees are moving back with the speed. For example, your bus is moving with a speed of 6 kilometers per hour. You feel that you are at rest and trees are moving back. Trees are moving back with the speed of 6 kilometers per hour here. That's it. Okay. So there is a clue here. So with respect to you, this boat which is moving with a speed of 14 kilometers per hour, as this will become in this opposite direction, you have to consider this 8 kilometers which is moving towards right. Okay, you feel that it is to be, its speed has been 8 kilometers per hour backwards. Okay, backwards. So therefore already it is 14 and this is 8. If you imagine like this, then what are you going to see here? What are you going to see here? 8. 8 you have to consider as your frame of reference. You're sitting in this boat and your horizontal speed is going to be 8 kilometers per hour. You feel that this boat is moving backwards with a speed of 8 kilometers per hour, but already it is having 14 kilometers per hour before. Its actual speed is 14 kilometers per hour and you are moving right side. Therefore, this boat appears to move like left side with a speed of 8 kilometers per hour now. Therefore, your 14 should be subtracted with 8. Therefore, for you who are the frame of reference here, for you this boat appears to move with a speed of 14 minus 8, which is equal to 6 kilometers per hour now. 6 kilometers per hour. So let me complete this in the form of a square, rectangle here. So what is the resultant? If this is 6 and this is 8, what is this going to be? Definitely it is going to be 10 kilometers per hour, which is called as the relative velocity or the resultant velocity. So this is called as a relative velocity, which is 10 kilometers per hour, because already your first second boat is moving with a speed of 14 kilometers per hour and your horizontal component is 8. You feel that this boat is moving back little bit, but as this boat is not at rest, already it is having 14 kilometers per hour, but with respect to you, as you already have some velocity, you feel that this boat is not moving with a speed of 14 kilometers per hour, because already you have got a speed of 8 kilometers per hour that has been reduced from 14 minus 8, 6 kilometers per hour. So for you, even though the second boat is having 14 kilometers per hour, for you who is moving along with the boat with a speed of 18 kilometers per hour, you feel that that boat is not having 14 kilometers per hour with respect to you, that is having only 6 kilometers per hour with respect to you, because you are going to become the frame of reference. I am solving the problem by considering you as the frame of reference here. So let us see what is going to happen now. So let me draw the similar type of triangle here. Okay. So if you observe this triangle, this is 6 and this is 10. This is 6 and this is 10. So this is 6 and this is 10. In between 6 and 10, what is an angle here? 53 degrees. So now you can consider this angle going to be 53 degrees. Then definitely this is going to be 37 degrees here. So this is 53 and this is 37 degrees. Let me draw a triangle like this now. Okay. So here I am drawing a triangle. Distance of closest approach. This is going to be the perpendicular line which I have drawn here. So let us see what are you going to see now. let us see, this is the distance of closest approach. This is the minimum distance here. As this is the minimum distance here now, and here if you observe, this distance is going to be 20 kilometers here now. This is the triangle which represents only distance. This is the triangle which represents only distance here. So already it is given in the problem that these two boats are at a distance of 20 kilometers. So I have written 20. So now this is okay. So how do you draw the triangle of 20 here? For example, in this triangle, if you take 20, if you want, you multiply with 4 here. So okay, 4, 5 fours 20. Okay, so this is again you will multiply with 4 here, 4 fours 16. Okay, again you will multiply with 4 here, 3 fours 12 kilometers. Now this new triangle, there is hypotenuse with not 5 as a magnitude, but this hypotenuse having 20 as a magnitude. That means if you multiply 5 with 4, you will get 20 here. And what is this going to be? Okay, 20, and this is 37. This is 37 means now the new triangle, if you are considering here, this is going to be 53 degrees here. Now if you observe, if 53 degrees, if one is 20, the other one is going to be 12 here. So this is 12 kilometers. Okay, and this is 53 means definitely this is going to become 37 degrees. And if one is 20, the other side of this 37 degrees is 16. Okay, so 16 kilometers. Now you got the distances of this case here. If you extend this here and extend this also, then this is going to be 90, and this is going to be the minimum distance here. Distance of closest approach, minimum distance, already we got it as 12 kilometers according to the concept of 37, 90 and 53. See here, actually this is 4 and this is 3 and this is 5. Okay, if you multiply with the 2 here, this will become 8, this will become 6 and this will become 10 here. If you multiply with 4, 4, this is going to become 16, and 3 fours 12 here, and this is 5 fours 20 here. Okay, so the new sides of this triangle is 20, 12 and 16 here. Okay, so this is, instead of 5 I have written 20, instead of 4, 4, 16 I have written, instead of 3, 3 fours 12 I have written. So new sides, same angles, but as the proportionality, as a similar, these two are similar triangles multiplied with sides are multiplied with 4 here. Now the answer for the first part of the question is find the distance of closest approach. So I got the minimum distance of closest approach as 12 kilometers. Now you need to find out what is the time. At what time they will reach the distance of closest approach, how much time it will take for them to reach to the distance of closest approach. You need to find out that time. It's very simple. So you need to find out the time here. Okay, so to find out the time, you consider relative velocity in this direction. What is the relative velocity in this direction? 10 kilometers per hour. Already we have got this one. And what is this distance? Distance is 16 kilometers and velocity is 10. Then time for distance of closest approach is nothing but distance by relative velocities. Distance in this direction you have to consider, relative velocity in the same direction you have to consider, and that distance is going to become 16, and relative velocities in this direction becomes 10 here. So therefore your answer is going to be 1.6 hours, because time you have to find out and it is in hours. Units are hours. So your answer is going to be 1.6 hours here. I think you understood. It's a very simple problem. Okay, just if you find that my video is easy to understand for you, then just keep one like. I'm not getting any personal benefit from your likes or your subscribers, nothing. Because likes, if you do like in this video, one thing the YouTube will do, YouTube algorithm will bring my video to topmost level and spread this video to the maximum people. That is the benefit of liking here. Liking will give a benefit to maximum number of students. That's it. I'm not having any personal benefit for them. For me here actually. Even if you subscribe also, I'm not going lakhs of amount or hundred thousands of amount like this. Nothing I'm getting. So if you subscribe, YouTube will promote my video and distribute my video to the maximum number of people. If you subscribe my channel, nothing I am getting now. I'm not getting nothing because I'm having a very small channel. I'm not earning any amount now. This is free of cost here. I'm not getting any amount now. But I'm doing all these things so that I can help the children during the lockdown. That's it. I don't have any personal benefit here. But if you subscribe my channel, this channel will be promoted by YouTube, and this channel, this YouTube will distribute my channel to maximum number of students. It will reach to maximum number of students who are poor and who are suffering from this type of problem solving methods. They don't understand physics neatly. That's why I want my video to reach maximum number of students. That is my selfishness. Nothing is there in this. Okay, thank you very much for listening patient. Okay.